And welcome back, and it is the 6th of May, higher plus 5 a day, and let's just go straight to the first one. We have another probability one, don't we? There are 9 counters in a bag, okay, 5 are red. Now I know I'm just going to write the same thing down, but it helps me remember, and 4 are white, 9 in total. Tom takes at random 3 counters from the bag, work out the probability they are not the same colour. Now, by far, the easiest way of doing this is doing 1 minus the probability they are the same colour. And that's going to be 1 minus the probability of red, 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 and minus the probability of white, 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 which is going to be 1 minus. Now, the first red is 5 over 9. The second red is 4 over 8, 1 less red, 1 less counter. And the third red is 3 over 7. And then I'm going to take away the first white, which is 4 over 9. Second white is 3 over 8, 1 less white, 1 less counters. And the next white is going to be 2 over 7. And then basically I'm just going to get my calculator and do this carefully. Now, 5 times 4 times 3 is going to give me 60. So it's 1 minus 60 over 9 times 8 times 7 is 504. And then I'm going to take away 4 times 3 times 2 is 4 times 6, which is 24. So taking away another 24 over 504. Calculator out really carefully. And that incredibly simplifies all the way down on my calculator to 5 over 6. Good question. Very reasonable exam style question. Next question. Now, I know this question. This question was on the first ever year I taught GCSE. Basically, it's very similar to this question, except it was a slightly different hexagon format. This is difficult. It is on a non-calculator paper. It is definitely something you should be okay with. It's pretty much the last question that appeared on the paper. Pause the video, give it a go if you don't already. I'm going to go through it now. Okay, the way to approach this question is you think about it as 2 different triangles. The clue is it looks a little bit, I mean it doesn't, but sort of like a cosine rule question. So I'm going to work out triangle A and triangle B. I'll do circles then you don't get confused with the letters elsewhere. So for triangle A, I know that BD squared is equal to 5 squared, so cosine rule, so 5 squared plus 5 squared minus, not plus, minus 2 times 5 times 5, so basically just cosine rule, cos of BAD, which is the angle here, BAD, so cos of BAD. So I've got an equation which has cos of BAD in it. I also know that BD squared, so BD squared, is also from triangle B is equal to x squared plus x squared minus 2 times x, which is x squared, cos of 60, where I know cos of 60 is a half. So remember, this is cos of 60 according to the cosine rule. Then I can tidy this up. So let's take A. Well, I can't tidy it that much, but I've got 5 squared plus 5 squared, which is 50. So A tells that BD squared equals 50, 25 plus 25, which is 50, to be clear, minus 2 times 5, which is also 50, cos BAD. Now just pause for a moment. When you're doing one of these questions, I can see a 50. I feel good. I feel like I'm going somewhere sensible. Triangle B. Now I can see again, I can simplify this a little bit. So BD squared equals x squared plus x squared, which is 2x squared, minus 2x squared times a half, which is just x squared, which is just x squared. Now, crucially, A is equal to B because BD squared equals BD squared, which means that x squared is equal to 50 minus 50 cos BAD. Remember what I'm trying to do? I'm trying to get cos BAD on its own. So let's do that. So let's say that cos BAD equals 50 minus x squared, so I've moved the 50 to the side, and then divide everything by 50. Now divide it into 2 fractions, so 50 divided by 50 is 1, and that's minus x squared over 50, and that, amazingly, is the thing I'm trying to prove, and I have done the question. That's terribly difficult. I remember when that first came on the exam, and people, and by people I mean students and some teachers, really struggle with that. But it's a really good question. It's not an unfair question. It's a hard problem question for the end of the paper. But if you got that, well done. Next question, let's move on. Show by using simultaneous equations. So it tells me what to do. The line y equals 5x minus 3 is a tangent to. Wow, this is almost A-level quality question. Let's think about what's happening. If I've got a curve, and if my line crosses the curve, well then I'm going to get two answers. If the line only just touches the curve, which is what a tangent is, then I'm only going to get one answer. So in other words, this question is basically saying, show there is only one x value to these two equations. So let's do that. So I've got 5x minus 3 is equal to y, and y is equal to x squared plus x plus 1. Let's rearrange. So 0 is equal to x squared minus 5x on both sides, so minus 4x. Add 2 to both sides, which gives me plus 4. Crucially, I can factorise this to x minus 2 squared, which means the only solution, I'm going to write this, so only solution is x equals 2. Therefore, and what does it say? Show by using simultaneous equations that the line in it is a tangent. So therefore, y equals 5x minus 3 is a tangent. That is a brilliant question. Like that question. I suspect some of you may not, but it's a really good question. Next and final question today. It's just algebraic fractions, isn't it? Okay, let's multiply. So I'm going to multiply everything by 2 times 2x minus 1. So let's deal with it first. So this one first. So that's going to be x times 2 times 2x minus 1, which is going to give me 2x. In other words, the 2x minus 1's cancel. And then I'm going to do this one. So therefore my 2's cancel, which gives me x times 2x minus 1. Let's write that slightly neater. 2x minus 1. And then this is going to be 3 times 2, which is 6, times 2x minus 1. Right, let's zoom in a bit because I can write a bit neater. Now, that's going to be, let's try and expand this carefully. It's going to be 2x minus 2x times x is going to be 2x squared. And then I've got minus x times plus 1 is plus x is equal to 12x minus 6 times minus 1 is minus 6. I'm going to move everything to the left. So 0 is equal to 2x squared from here. Move 2x plus x is 3x. Take away 3x from both sides is going to give me 9x. I've got no other numbers, so it's just going to be minus 6. Wow. Can I factorise this? I don't think I can factorise this. I'm just going to go straight to quadratic formula. So x is equal to minus 9 plus minus the square root of 9 squared, which is 81, minus minus, because there's a minus here. So plus 4 times 6 times 2, definitely can't factorise this, divided by 2 times 2, which is 4, and that gives me, right, now let's do this carefully, because I got the one wrong a couple of days ago. So that is minus 9 plus minus the square root of 129 over 4. So the plus version is going to give me 0.58945. And the minus version is going to give me minus 5.08. And then some more, so 945, etc. Now back to the question, what does it want? Solve, which I've done, give your solutions to one decimal place. So therefore I'm going to take my answers and I'm going to round to one decimal place, which gives me 0.6 and minus 5.1. And that's it, question done. I think I said this yesterday, I'm going to say it again today. It has been an excellent mix of questions today, really good. A really, really difficult problem question in the middle, some difficult questions along the way. I've really enjoyed that, but then again, I'm not doing an exam, and I know a lot of people watching this video are, but really good practice for those harder exam questions. Let me know how they went for you. Like, subscribe. See you tomorrow.